Welcome to the presentation about FMI Additive, part of the FMI Group and Dutch Technology Alliance. FMI Additive is located in Tilburg, which is right in the center of Eindhoven and Randstad region, making it easy to visit our partners nearby. At FMI Additive, we've been one of the early users of metal AM in the Netherlands. We started using AM back in 2015 with an EBM machine, which we'll tell more about later. Back in those days, we were the only manufacturing medical implants, but over the last 9 years, we have expanded to 3 EBM machines, and in 2016, we also added SLM machines to our production. Besides expanding our machinery, we also started manufacturing of tooling for the healthcare industry and entered the semiconductor market. On the image in this slide, you will see two of our constant laser SLM machines, which we particularly use for the tooling and also integrated implants. But the thing is, FMI is part of a larger holding, as I mentioned, and we don't just do additive manufacturing. FMI is a much bigger company, and we have a lot more business units like instrument, mechatronics, precision and machining. But as of lately, FMI has also expanded abroad with a business unit creating high-tech packaging in Bosnia. FMI Additive also used to be part of Instrument, but has been separated to allow for expansion and more easily to supply non-medical markets. Being part of a larger company creates a lot of benefits for FMI Additive, as we can produce parts and fully process them without ever needing an external company, making our production flow a lot more streamlined, which obviously will also reduce the cost per part. So now I have a slide for you in which you can see the process flow that we do at FMI Additive. This is mainly for our additively manufactured parts. I will keep it brief and not go into too much detail here. So right at the start, when we receive a request from a company, we will first check whether it makes sense for us to produce and check if AM is really the best solution for our issue or problem. If so, we will move on to engineering. Here we will optimize the supply design by the customer. Once this development is completed, the work preparation is executed so it can be manufactured on our machines. After the parts leave the printers, they will also leave our Tilburg site and move to one of our other FMI locations for processing. Here we have fully finished the parts so they can be used right away when they arrive at the customer. In the meantime, we will work together with the customer to keep the quality in check and improve where we can to strive for perfection. As seen as a second step in the process on the previous slide, design for additive manufacturing, or in short, DFAM, is where the most significant difference is made between companies. DFAM is a skill that doesn't come with the machine when it's purchased. DFAM is a skill that requires you to make your hands dirty at the machine from time to time and can only be mastered through an iterative process. Since FMI is using AM in production for 9 years already, DFAM is really where we can make the difference. We make sure that our DFAM work is near perfect to ensure a couple of different things. So the first thing we explore is the different processing steps that we can use for a part, which will also be required to match the required tolerances while also minimizing the amount of processing steps required for the part itself. Also minimize the risk of production failures. When even a single part out of the 100 in a build starts to warp, it can affect every other part during the build or even stop the build completely. Therefore, reducing the risk of failures is really necessary. Maximizing the production efficiency is something that aligns with minimizing production steps, but what also happens during work preparation, in which builds are prepared, where machine time can be used as optimal as possible. And finally, FMI primarily works on series production orders. To validate products, DFAM is very important, so the most optimal design can eventually be chosen for the series production. From powder to product. So the parts that are designed and improved via DFAM can be printed with two different kinds of machines at FMI, either via EBM or SLM. EBM is a technology that uses an electron beam to melt the powder, and SLM uses a laser. The advantage of electron beam over laser is that the process happens at a temperature of 400 degrees for titanium. This reduces the internal stresses of the part a lot. It can make parts a whole lot quicker, and with the new machines, they don't even require support. However, with laser melting, you will have a much better surface finish and a lot more accurate dimensions. In all of our print cycles, we add testing coupons to ensure the quality of the parts themselves via statistical process control. Once the print cycle is finished, the parts can go straight to the customer if they would like, but if they want to do the post-processing themselves, they obviously may, or the parts go into our internal process cycle to fully finish the product for the customer. When the parts come out of the printer, they're never really completed. They require a multitude of processing steps before they are truly functional parts. Therefore, AM is not a standalone process in a greater scheme of production. And since FMI Additive is part of a greater business, which I mentioned earlier, FMI has a whole range of different machines that can be used for the processing of our printed parts. All of our medical parts are processed at our medical production site in Schiedam. The non-medical parts can usually be processed at another FMI location. So for now, I have some of our examples I would like to show. First off, we have this hydraulic manifold you can see on the top right. The manifold cannot be made with traditional production processes because of the geometry in combination with the channels. Therefore, AM offers the solution to making this part anyway. Besides makeability, AM also offers a reduced lead time because a complex part can be made more easily. But it also offers a significant weight saving, as only necessary material needs to be made. So in this image we can see an integrated spine implant. This is one of the products we've been making for a long time already. The production for this article has been fully optimized, resulting in a very predictable production result time after time. In the build cycle or the print cycle, we produce around more than 300 of this part at the same time. The customer designed a custom ladder structure for optimal bone growth, and we've optimized the production itself, so we've minimized the supporting surface required, and this has also minimized the processing steps needed to process this part. The image that we see on this slide on top right is an integrated spine implant tooling for the implant. This particular part is used to lock the screws in place that is used for a certain kind of implant. This product has been optimized for series production to agree that a multitude of parts can be processed at the same time by our machines. So, for example, this range or this series of products, they're all clamped into a machine at the same time, so they can all be processed at the same time and don't need to go one by one. For our final example, we have an orthopedic implant. This particular implant is made with EBM technology. This is visible by the surface finish that is visible on the part, the rough part primarily. This part shows nicely how a very rough surface finish on one side while having a very smooth finish on the other side. The open structures cannot be made with other technologies than AM, and in combination with the rough surfaces, this makes the features perfect for bone attachment. And this was our quick presentation about FMI Additive. Thank you for listening, and hopefully we'll see you later.